All right, thank you so much, Michael. We're now going to
You're
hear
welcome.
from Vince Ledvina from the University of North Dakota on construction of an Aurora camera in North Dakota to aid in citizen science and space weather applications. So I am
Yes,
going
thank
to
you.
screen share.
Are you able to hear me?
Yes, we are.
Okay, can I actually screen share my own screen?
Yes, you most certainly may.
Because it's probably better. All right, share computer sound. On here. All right. You guys able to see this?
Yes.
Yeah,
Right.
looks good.
Hello, everyone. My name is Vincent Ledvina. I am a sophomore undergraduate physics major at the University of North Dakota. And today I would like to talk about our latest project, installing an Aurora camera in a remote area of North Dakota. Aurora cameras are important tools for scientists as well as Aurora enthusiasts. Aurora cameras allow for the visual study of auroras, which can reveal novel types of auroras and help in classification and estimation of overall auroral strength. An Aurora camera also offers location-specific data, which can help correlate auroral strength with latitude and other space weather conditions. Aurora cameras also offer very high time resolution data with some possible real-time video capture. This type of data is very useful when studying fast-moving and transient types of aurora. An Aurora camera is also an essential tool for aurora chasers who value real, direct observation of auroral strength over more indirect methods, such as reading magnetometers or solar wind data from satellites. At mid-latitudes, the need for an Aurora camera is even more apparent. It's a fact that the amount of Aurora cameras in mid-latitudes is extreme. And during auroral storms, these regions often experience rare types of aurora, such as substorms and steves. So in order for more complete study of these events, there needs to be more coverage of these areas. Furthermore, most aurora chasers are also located at these mid-latitudes. So observations from North Dakota would make a huge difference to those in the northern portions of the United States and Lower Canada. As you can see, an Aurora camera is desperately needed in North Dakota to aid science and Aurora enthusiasts. As for the technical details, the Aurora camera system will consist of a north-facing Sony A7S II mirrorless camera paired with a Sony 24mm f1.4 GM lens, along with a ZWO Astro camera paired to a fisheye lens, which will act as our all-sky camera. The north-facing camera is a top-of-the-line model and will offer the unique ability to record the aurora in real-time 24 frames per second in 4K resolution. The all-sky camera will be able to record images at a slower interval, but offer a field of view of the entire sky, which is useful if aurora displays go overhead. Furthermore, the specific sensor we will be using in the all-sky camera has been tested by a team at the University of Svalbard to be well suited for aurora and is used in their Boreal auroral camera constellation. The location of the camera will be on site with the facility operated by the University of North Dakota's Astro Department. Martin's Observatory is located in Inkster, North Dakota, and has lows of light pollution, a 2 on the Bordeaux scale, as internet connection. You can see a picture of the facility in this section of my post. The cameras would be in some sort of weatherproof dome, and it would have great view. It would have its own Twitter account so that it could tweet when the aurora was visible and be integrated into the Aurora Source website. The images would also be available to download by anyone. As far as integrating this camera with scientific efforts, as I said before, images of rare aurora from both cameras would be helpful in determining some of their spatial characteristics, and the high time resolution of the data would mean that detailed studies of these events would be possible. The Aurora cameras would be integrated into the Aurora Source project, which I'm also a part of, and we have plans to integrate this all-sky camera into the Mango and CAMS projects, which study airglow and survey meteor fireballs respectively. The Aurora camera will be integrated into the Northern Sky Astronomical Society, which is North Dakota's largest astronomy group, of which I'm the president of, and serve as an aurora chasing tool for the many online groups and communities. I also want to acknowledge all of the citizen science and Aurora science communities that have made significant efforts in this space already, and really, without those communities, this project would not be possible. Given the impact that this project will have, and given that we're still in our early stages of planning, we would love to see collaborators with other projects and efforts. I know that an Aurora camera in North Dakota will be useful to so many groups of people, but I'm only a sophomore undergraduate, so any guidance or advice would be greatly appreciated. And I'm already really grateful to be attending HamSCI, let alone presenting a project. So with that, that is our Aurora camera project. Thank you for your attention, and I hope I can answer any questions you all may have. Thank you. All right, that is that. Any questions?
Yeah, I have a question. As far as the hardware camera that you picked, are you using a 4K 24 frame per second? Can you give us maybe what I'm looking for is that's a pretty high performance camera. So the question is, how important is the frame rate and how important is the resolution of the camera in relation to the data that you're trying to collect? So if I had a choice of a lower performance camera, would it be better to have less resolution and a higher frame rate and keep the frame rate high, or would you be willing to trade off frame rate for resolution?
So the reason why we chose the Sony a7S II was because that's really it's one of the only cameras that can record the night sky and in basically real time. So the reason why we chose that is because there's really nothing else available. And in terms of quality, that camera it's only 12 megapixels, but because of that, its actual photo sites are really large, so it can collect a lot of light. And in terms of actually getting the most quality out of your photos, you would want a lower frame rate and you would want lower megapixels so that you would have more light collected, but that's the trade-off when you're shooting real time.
Okay, and that is there another specification like a sensitivity or something that goes along with different camera types? Because you mentioned the larger capture area, so it sounds to me like you do better in low light situations, which is what you're trying to do with the night sky.
Right. Yep. Exactly. Yeah. And I've actually worked with that camera before, and it's really great. I've shot some real-time video of the Aurora on it at 24 frames per second from North Dakota, and it works just fine. So yeah, it's been tested. It's been proven to work. So
is it expensive?
That camera is relatively cheap. I mean, I don't know exactly what that means, but it's about $2,000. So yeah.
Okay.
And actually, maybe,
So it's not too bad.
do you have a cost for the other camera, the fisheye camera?
Yeah, the HamSCI camera, the one that the University of Svalbard did tests on, I believe, was only $600. It's a bit of an older model, so I'm gonna have to look and see if there's if they've done tests on a newer model. So that one's from 2014, I believe, and then the lens for that, I believe, is only around $600 as well. So
could we get useful science out of a lower cost system?
yeah, I think so. I think it all just kind of depends on what you want to accomplish with the cameras that you put on there. You know, if you're just doing an all-sky camera that's super cheap, maybe your only goal is to just say, oh, there's Aurora here, and then that is your one data source. But if you wanted, let's say, really high quality observations, really high quality observations that you could actually make quantitative estimates of, then you would probably want a more expensive camera. But in terms of just the data, I don't think there's any limit to the cost at which it can be useful.
What do you think, Liz?
I think actually, Scotty, I think some of the questions you were asking were kind of like, what are the specs for the data rate? How much data is this camera going to produce? Which is something that we can calculate, you know, how big per, you know, what's the one night of observations would be what sort of size. And then that can be scoped into the personal space weather station, as well as more details on what the price points might be for one camera or two cameras. So, you know, that's definitely something that would be a good idea to see how those specs are kind of matching up.
Yeah, and that was my next question is what interface does it use? Is it like, is it transfer data over USB?
Yeah, it does do that.
Okay, so that's good.
This is Phil. I had a question about, in the radio world, we always worry about the rising tide of RF interference, right? That's always the case. And in the optical world, of course, light pollution is a big thing. I just don't know, are there people who are just like, I know there's the International Dark Sky Association, which tracks, sort of the gradual increase of background level. What's it like in North Dakota? Do you see a problem in a few years with being able to make these kind of images, or are you guys still going to be okay for a while?
I think we're going to be fine. There's not a lot of people out there. And where we're building the Aurora camera, there's no cities that are within 20 miles north of that. And I don't imagine there to be any in the next 50 years. So
beautiful.
Is it a university site as well? It's like a university
observatory
site.
Yes.
So it's already got infrastructure for.
Yep. It already has internet. It has power. It has all that ready to go, basically.
Right. It's that last mile that often kills it if you're trying to get it out in some random location. But yeah, clustered things like observatories that are especially run by universities are great.
This is Tamitha. Let me, if you don't mind me just mentioning one thing. Oftentimes, light pollution isn't nearly as frustrating as we might think, at least in terms of not necessarily perhaps for doing science when it comes to Aurora, but at least it's the detection of it. Aurora oftentimes is so bright that it can even compete or beat out a full moon. So I don't think light pollution. I've seen many images of people taking pictures of Aurora in many locations right out their bedroom window, competing with street lights in their neighborhoods. So I think even with heavily polluted, light polluted regions, Aurora cameras will still have a good function simply because Aurora can be incredibly bright. It's nothing like looking at the celestial sky.
Great.
Yes, definitely.
All right, we have about 3 minutes. Does anybody else have any other questions? Okay, we'll go on and get set up.